Welcome to the first video of the third unit. Here we're starting off Module 9, looking at basic probability. In Unit 2, we learned about descriptive statistics, which describe things that have already occurred. We looked at various measures, such as mean, median, mode, range, standard deviation, and variance, to describe data sets, as well as portraying them using charts and frequency distributions. In this unit, we'll be learning about inferential statistics, which allow us to draw conclusions and make predictions on how likely certain things are to occur. And it often involves given information of things that have occurred in the past or theory. Probability is a measure that represents the likelihood or chance that an event will occur. So it holds a value between 0 and 1. It's really important to recognize that probabilities as well as percentages go hand in hand. So the probability is the decimal representation of the percentage of an event to occur. In this first example, it says here, there is 50% chance that a particular antibiotic therapy will be successful. We can express that 50% as a decimal. So it's a probability. So the probability that that particular event occurs would be equal to 0.5. Probabilities are commonly reported to 4 decimal places. We'll be working with that when we look at the normal distribution. So I'm going to report this 0.5 using 4 decimal places as 0.5000. In Math 117, you learned how to convert between decimals and percentages. So if you're given a percentage of 50%, to convert it to a decimal, you will divide by 100 and then drop the percentage sign. Alternatively, if you have a probability and you want to report your answer as a percentage, you will multiply the probability by 100 and add your percentage symbol. So now that we know that our probability will be reported as a value between the values of 0 and 1 inclusive, let's talk about what those numbers mean. So a probability of 0 means that our event is impossible. It will never occur. And as we head towards 1 on our scale, the probability of the event occurring increases. And when it is equal to 1, it is certain to occur, so it will always occur. Right halfway, so at 0.5 or 50% chance of occurring, it's when there's an even chance. So perfect example of that is your coin flip. If it's a fair coin, so it's not weighted differently, it will have 50% chance of getting heads and 50% chance of getting tails. Whereas with a dice, because it has 6 sides, there's 1 in 6 chance of getting any of those numbers. So it's a lower probability. And if looking at this ball example, so if you have 5 balls, 4 of which are blue and 1 is red, the chance that you will select a blue ball from a random pile of those 5 balls would be 4 in 5 chance, or 0.8 probability. It's worth mentioning the percentages that would go along with these probabilities. So if an event is impossible, it will never occur, it's 0% chance, and a probability of 1 means that it's 100% likely to occur, so it's certain. For proper probability notation, we use the capital letter P to describe the probability, and then in brackets, we're going to report what the particular event is of occurring, and we'll define what an event is in a moment. So say we're flipping a coin, the probability that you get heads in a coin toss is equal to 0.5000, or the probability when you're rolling a dice of x equaling 3, so getting a 3 when you roll your die is 1 out of 6 chances and can be reported as 0.1667 if we round to 4 decimal places. So here's a practice question. It says, match one of the probabilities that follow with each statement of likelihood given. The various probabilities that we have to choose from are 0, 0.01, 0.3, 0.6, 0.99, and 1. You can see that these values increase and are listed in order from 0 to 1. Okay, so the different statements. So we have, this event is impossible. It can never happen. We would associate that with a probability of 0. So if it can never occur. This event, so number 2, this event is certain and will occur on every trial. So that's 100% chance of occurring, or probability of 1, and that is scenario 2. Number 3, this event is very unlikely, but it will occur once in a while in a long sequence of trials. Okay, so when something is extremely unlikely, it means that it's very close to 0, and the closest value that we have to 0 is 0.01, which means that in this case, so for that probability, that 1 out of every 100 trials would produce that event result. Okay, and then part 4, this event will occur more often than not, which means most of the time, more often than not would be just more than half. And we would associate that with a probability of 0.6. Before we go any further, let's define some terminology for probability. So an event, procedure, event, and trial all refer to actions that produce a measurable result. An outcome is a particular result of an experiment. So it's a subset of the sample space. We should define sample space, which is a list of all possible outcomes for an experiment. When we're performing an experiment, procedure, event, or trial, often what we're measuring is some sort of result which can either be described qualitatively or quantitatively. When we list all those results, possible results or outcomes in the sample space, we want to list it in set notation. So let's look at some examples. So if we have a true or false question, the set or sample space set of possible outcomes would be that you can either answer your question as true or you can answer it as false. Often we use short forms, so T and F, to represent true and false. Really, you can use any short forms you like as long as you define them within the question. You can then, in turn, take any of those outcomes and report a probability to go along with it. So the probability that your true or false question has a value of true would be 50% or 0.5. Then we can look at 2 true or false questions where we have a sample space. We have 2 questions, so you can either answer both of them true, you can answer the first one true and the second one false, or you can do false and then true, or false and false. So there are 4 different possible outcomes, 4 outcomes within our sample space. And again, you could look at the probability of any of those events occurring. So the probability that both of them are true. And we'll look at how to calculate that probability later. So pause the video and practice defining the sample space for the following experiments. Then you can play the video and check your solutions. So if we have an experiment for a roll of a dice, the possible outcomes of one single dice, you can get a 1, 2, 3, 4, 5, or 6. Any of those possible outcomes can occur. Or if you're tossing a coin, you only have 2 options of what can occur, so heads or tails. If you're tossing 2 coins, so similar to our last true or false example, you can have both of them can be heads. You can have heads and tails, tails and heads, or both tails. And our last example, so if you have an individual's blood type being tested with RH factor, the sample space would be A RH positive, A RH negative, B RH positive. I'm just going to say B negative, AB positive, AB negative, O negative, and O positive. You could also write a sample space where you're not considering the RH factor, where we only have A, B, and O. So the sample space is half as large. Tree diagrams can be used to determine sample spaces with repeated trials. So we have a tree diagram here that shows the outcomes for an experiment with multiple trials. We can look at the probability of having a disease versus not having that disease. And you can see that the sum of these probabilities is 1, because either you have it or you don't. Then, if you have the disease, we can test whether or not a particular test for that disease reports a positive test or a negative test. So when a person has the disease, there is 99% chance that they test positive, whereas there's a 1% chance that they test negative. And we call this a false negative. So where they don't think that they have the disease, but they in fact do. And when you do not have the disease, there is a 0.005 probability or 0.5% probability that they still test positive, and that's considered a false positive. And a 0.995 probability that they do test negative and show that they do not have the disease. In the next set of notes, we'll be looking at how to calculate the probability that one of these 4 events occur. So the 4 events would be you have the disease and you test positive, have the disease, test negative, or no disease, test positive, and no disease and test negative. So that's just a bit of a preview into what we'll be doing in the next module. In this set of notes, we're simply using tree diagrams to organize and determine the actual sample space. So we want to draw a tree diagram to determine the sample space for the results of flipping a coin 3 times, and we're going to use H for heads and T for tails. So we're going to build our tree diagram. In the first flip, there are 2 possibilities. So you either get heads or tails. Then when you flip it again, we can either get heads or tails for the second flip, and heads or tails again. So if you first flipped heads, in the second flip you can do heads or tails, or if you first flip tails, again we can do heads or tails for the second flip. And in our third flip, it's always just 2 options of what can occur with each flip. And using that tree diagram, we can work down each of the branches to determine the sample space. So working along the top, we get heads, heads, heads. And then in the second branch, we can get heads, heads, tails, heads, heads, tails, then head, tails, head, head, tail, tails, and so on. And when we see that our event of flipping a coin 3 times has 8 possible outcomes within our sample size, and we can calculate the probability of each of these occurring. In the next video, we'll be looking at calculating probabilities, starting off with some simple probabilities and working up to some more advanced probability techniques in the next module.